Hey guys, Travis Gillespie here. Today we're going to be talking about inverse variation. So let me just get that written up on the screen real quick. Alright. Okay, so let's just talk about what inverse variation is. So a common trait of inverse variation, or just kind of like a general rule, something to help you remember what it is as one variable is increasing, the other variable, so we'll call this y here, the other variable will decrease. So as one variable increases, the other decreases, or the reverse could happen. So as x decreases, y increases. So y increases. Okay, now I'm just going to pause for a second and consider what I said, because the statement was just a general statement about traits, and it's not the entire picture. Also, I'd be contradicting something I stated in another video, so I'm going to go pull up that information, and I want to take a look at it. Okay, so in a previous video, when talking about direct variation, one of my equations in that video had a negative value in for k, in this case -4. So when running through the table here, let's just backtrack for a second. When running through this table, as x increased, -4 caused the y value to decrease. So as x increased, the value for y decreased. Or, moving in the opposite direction on this table, as x decreased, -4 caused y to increase. So as x increased, y decreased, or as x decreased, y increased. So this looks similar to what I was just talking about using inverse variation, or looking at inverse variation. So let's just backtrack back to that real quick. Okay, so here's the missing piece here. One variable will increase as the other decreases in proportion, so that it's the product that will stay constant or remain unchanged. So what this says here is if we take x and we multiply it by y, we're going to get a product. And if we continually do that with a data set, if that product remains constant, we'll call that k. So k is the constant, and it's equal to the product of x and y constantly. And we call this inverse variation. So we have here that k, it's equal to the product of x and y, or another way of thinking about it is that the product of x and y will give us our constant of variation. Okay, so now I can manipulate this equation if I need to or want to, and I'm going to talk about that in just a little bit, but I just want to backtrack one last time. So for inverse variation, we're looking at the product of x and y, which will give us our constant. But let's just backtrack to direct variation and see the difference real quick. Okay, so the way I like to think about direct variation is it's the ratio of y over x will give me my constant. Whereas for inverse variation, it's the product of x and y that give us k. In fact, I'm going to write that over here. For direct variation, one last time, we'll just take a look at it. For direct variation, the ratio of y over x, and I'm going to fix that k real quick, the ratio of y over x gives us our constant for direct variation. For inverse variation, the product of x and y will give us our constant of variation k here. Cool, I'm going to get rid of that information. Great, now I can actually manipulate this equation. I'm just going to do that over here. So again, we have k, it's equal to the product of x and y, and I'm going to isolate y over here. Okay, so I'm going to divide both sides here by x and by x again, and these two will cancel out. I'm left with k over x is equal to y, and I could rewrite this as y is equal to k over x, and I'm going to do that over here. So y, it's equal to the ratio of k over x, and I'm going to get rid of all that stuff too. Cool, so when you hear the statement that y varies inversely as x, so what that means is if your value for x is increasing, then your value for y is going to decrease, and it's going to decrease by the same factor that x is increasing by. So what that's really saying is that the product of x and y, x times y, is constant. Alright, let's go ahead and graph a couple of inverse variation functions. Okay, so we have our first function here. F of x is equal to 4 over x, and we can actually look at this setup as being similar to that for inverse variation here. Y is equal to k over x. So f of x would be the same as y, and 4 over x would be the same as k over x here. So what this function's really saying is, what's y equal to, f of x being y, what's y equal to when we substitute a value in for x here? All right, so let's get started. And I'm going to just change colors. So the first value I'm going to look at is -4. So -4 here. So f of -4 here is equal to 4 over -4. So all we're really saying here is, what's y equal to when x is -4? Well, what's 4 divided by -4? It's -1. So f of -4, or y, it's equal to -1. So I'm going to substitute -1 in there. So we have -1 here. All right, so f of -2, let's put that here, f of -2 is equal to 4 over -2. So 4 divided by -2 will give me -2. So f of -2 here, in fact, I'm going to fix that, f of -2 is equal to -2. Okay, so let's take a look at -1 now. So f of -1, and I changed colors just to separate this work a little bit more. So f of -1 is equal to 4 over -1, and 4 over -1 will give me -4. So f of -1 is equal to -4. Okay, so -1/2 now. I'm going to work that one over here. So let's just do an arrow. f of -1/2, it's equal to 4 over -1/2. So you're going to flip this reciprocal and multiply. So I have 4, and I'm going to just choose a new color real quick just to color code this. So 4 here, 4 as a fraction is 4 over 1, and I'm going to multiply that by the reciprocal of -1/2. So now I'm going to flip the reciprocal of -1/2, and I'm just going to put the negative sign out to the side here. It can really be anywhere. It could be in the numerator or denominator, but I'm going to make this -2 over 1, or just -2. So it's really just 4 times -2, which will give me a value of -8. So now I have -8 here. Okay, so what about 0 here? What about 0? If I take f of 0, well, even before I work this out, just think about what's going to happen when I substitute 0 in for x here. So we have 4 over 0, and you can't have 0 in the denominator, so this is going to give us a value that we call undefined. So no 0 here, it's undefined. Let's move on to 1/2. So f of 1/2, it's equal to 4 over 1/2. So I'm just going to pull this information out. I'm going to flip the reciprocal and multiply it by 4. So here I have 4 over 1, 4 over 1 times the reciprocal of 1/2 is 2 over 1, or simply 2. So 4 times 2 is 8. So when x is 1/2, y is 8. And I'm just going to clear some of this information off. We don't need it anymore. So what about x is 1? So what about when x is 1? Well, I think you're going to start seeing the pattern now. When x is 1, so f of 1 here, f of 1 is equal to 4 over 1. All right, and I'm just going to write these other two out now. So f of 2 is equal to 4 over 2. And then finally f of 4 is equal to 4/4 here. All right, so 4 over 1 will give me a value of 4. 4 over 2 will give me a value of 2. And 4 over 4 will give me a value of 1. Okay, so when x is 1, y is 4. When x is 2, y is 2. And when x is 4, y is 1. So let's go ahead and plot all this information, or graph all of this information, and see what the graph actually looks like. I'm just going to clear out that screen. All right, so the first point I'm going to plot is -4, -1, and I'm not going to even number this coordinate plane. I'm just going to assume each tick mark represents one unit. So when x is -1, -2, -3, -4, y is -1. Cool. So when x is -2, y is -2. So 1, 2, -1, -2, -1, -2. And in fact, I'm going to fix that. There we go. All right. And then when x is -1, y is -4. So -1, -1, 2, 3, and 4. When x is -1/2, y is -8. So -1/2, and y is, this is -4, 5, 6, 7, and 8. So I'm going to plot it right here in the center. And you can see there's a curve that's starting to take place here. And I'll come back to this in just a second. Let's go over to the other side. So 1/2, when x is 1/2, y is 8. So when x is half, y is 1, 2, 3, 4, 5, 6, 7, 8. So right in here. When x is 1, y is 4. In fact, I'm going to fix that last one real quick. There we go. So when x is 1, y is 4. X is 1, 1, 2, 3, 4, y is 4. All right, so when x is 2, y is 2. So 1, 2, 1, 2, right in here. Okay, so finally, when x is 4, y is 1. So 2, 3, and 4. And y is 1. So again, we're starting to see a curve here. All right, so what I'm starting to see here is a curve. So if I were to actually draw a line through these points, what we'd start to see is that as this line approaches the x-axis, it will never touch the x-axis. And in fact, it's just going to come very close to it and never touch it. Same thing if the line moves in the opposite direction. It will come close to the y-axis, but never actually touch the y-axis. And I want to just fix that just a little bit. So it will never touch it. It will come close, but never touches it. And I'm going to do the same thing along the other side. So, okay, so as the line approaches the y-axis, it comes close to it. It gets closer and closer, but it never touches. As the line approaches it, it gets close, but it never touches. Okay, so now I'm just going to look at these two lines here and then just compare them to what I stated earlier. As x increases, y decreases. And if we run along this chart here, well, as x increases, the value for y decreases. If I run in the opposite direction, well, as y increases, the value for x is decreasing. And now I can go and look down here at the same thing. As x is increasing, as I move along the x-axis, as x increases, y decreases, or in the opposite direction, as I move to the left in the x direction. As x decreases, y is increasing. The value for y is increasing.